Hello friends, today we are going to learn a new topic. So this will give you an added advantage. So you'll be having something new with you. You have learned something new which you should be proud of. So today's topic would be basics of trigonometry, and this will be helpful to you if you are thorough with this, not only in maths, higher mathematics, but also in physics and other science subjects, science and engineering subjects. So try to learn and understand the basic concepts of trigonometry. Okay, so let's get started. So basically, to define with, to understand what exactly is trigonometry, let us try to understand and give the definition of trigonometry. Okay. Now, what do you understand by the word trigonometry? Now, trigonometry is a branch of mathematics. Okay, what does it do? Now, it deals with the ratios of the sides and angles of a right angle triangle. In fact, it can say any triangle, but to begin with, we normally begin with a right angle triangle. Okay, so mathematics has got several branches like arithmetic, algebra, mensuration, geometry, so on and so forth. Okay, now trigonometry happens to be one of the branches of mathematics, correct? Now, as I told you, it only deals with the ratios of the sides and angles of a triangle. Let's go and try to understand what exactly those ratios are and how do we define them. Okay, so to begin with, let's take a right angle triangle. So right angle triangle, we all know that angle B is 90 degrees. Okay. Now this angle will take it as theta. Theta is a Greek alphabet. Okay. So alpha, beta, gamma, delta, all those are Greek alphabets. So normally in trigonometry we use theta mostly. Okay. So always theta is used when using trigonometry. So theta being one of the Greek alphabets, and this particular topic came from there. Okay, so because tri means trigonometry, triangle. Okay, so theta is the angle what we normally take. So here this angle I am taking it to be theta, right? Now what we do is the six ratios. We will try to summarize it. But before that, let me tell you, the side AB, we find the side AB opposite to this angle theta. Hence, we call this AB as opposite side. Okay. Now this side BC, we find it that this happens to be adjacent to theta. So we call this side as adjacent side. Okay, and you all know that in any given right angle triangle, AC is always called the hypotenuse. Okay, so now we know what is an opposite side. So side opposite to the angle theta. Okay, ACB is theta. Angle ACB is given the name as theta. Angle ABC, angle B is 90. ABC, angle B is 90. This is theta. Now the side opposite to the theta, lying exactly opposite to theta, is called as the opposite side. This AB is called as the opposite side. Adjacent to this theta is called as the adjacent side. And this side AC is always called as, anyway, you know that it is called as hypotenuse. Okay, so far so good, correct? These are only the basics which you have already learned in your primary section, right? Earlier classes. Now coming back to trigonometry. So what are the, I was talking about the 6 ratios, remember? Now what are those 6 ratios? Let me define. The first one would be sine theta. Sine theta, theta and sine are inseparable. Sine theta. The sine theta is defined as opposite side by hypotenuse. Okay. So sine, what is sine theta? Sine theta is opposite side by hypotenuse. Correct? Now, similarly, cosine theta, it is actually cosine theta. It's a complement of sine, but in short, we call it cos theta. What is cos theta? Cos theta is adjacent side by hypotenuse. Okay. The next comes the tan theta. It is normally called as the tangent, but in short we call it as tan theta. Okay. Tan theta is what? Opposite side by adjacent side. Now, as I told you, there are 6 ratios. These 3, sin theta, cos theta, tan theta, we have already defined. Okay. So what is sin theta? Opposite side by hypotenuse. Opposite side by hypotenuse. Cos theta is what? Adjacent side by hypotenuse. And tan theta is opposite side by adjacent side. Now the rest 3 are opposite of this. Now next will be cosecant theta. Is what? Opposite of this, 1 by sine. So hypotenuse by opposite side. Next will be secant theta. Secant theta is nothing but 1 by cos. Okay, so hypotenuse by adjacent side. The last one will be cotangent. Okay, in short we call it as cot theta. In short we call it as cot theta. That will be the last one. So what is cot theta? Cot theta is again 1 by tan. So adjacent side by opposite side. Okay, so if you are thorough with these basics, then the rest of the trigonometry will really become easy for you. Okay, let me just repeat it for your clarity. This might be clear to you about the triangle. What is the opposite side, what is the adjacent side, and what is the hypotenuse. Okay, hypotenuse anyway you know. The side opposite to the angle theta is called as the opposite side. The side adjacent to theta is called as the adjacent side. Okay, this angle is 90 degrees. In any right angle triangle, this is 90 ABC. Okay, now sin theta, 6 ratios, 1, 2, 3, 4, 5, 6. Sin theta is always opposite side by hypotenuse. Remember that. Now, the easy way of remembering is, supposing you are finding it difficult, finding it hard, so always remember that sin theta is equal to opposite side by hypotenuse. That means if you remember SOH for this. What do you mean by SOH? Sin theta is opposite by hypotenuse. Okay? So, sin theta opposite by hypotenuse, SOH, if you remember, it becomes easy for you. Now you know sin theta is opposite by hypotenuse. Okay? Similarly, cos is adjacent side by hypotenuse. Cos theta is adjacent side by hypotenuse. How do you remember this? COH. Cos is, CAH. Cos is adjacent side by hypotenuse. Okay? Now, tan. How do you remember tan? Tan is opposite side by adjacent side. Tan is opposite side by adjacent side. So remember this SOH, So sine is opposite by hypotenuse, sine. Cos is adjacent side by hypotenuse, Tan is opposite side by adjacent side, tan is opposite side by adjacent side. So that is a shortcut to remember these three. Okay, these three are again the opposite of these. Cosecant is again nothing but 1 by sine. Okay, so that will be 1 by sine is hypotenuse by opposite side. Secant theta is hypotenuse by adjacent side, and cot theta is always adjacent side by opposite side. So I hope so far it's clear to you. Remember, these are the basics. If you're thorough with this, the rest of the trigonometry I'm telling you becomes easy for you. Okay, so if you want, you can even practice. So if you want to practice, we can practice again. I think I'll give you some numbers and then let's see whether you can do it. Supposing if I give you some numbers over here, I'll say BC. If I measure BC, the side BC is 3. Okay, this side is 4. This side is 5. Okay, now coming back to sine theta in terms of numbers, this side is 3, opposite side is 4, adjacent side is 3, and hypotenuse is 5. Okay, now how do we find out sine theta in terms of these numbers? Okay, so what is sine theta basically? Sine theta is opposite side by hypotenuse. So opposite side number is what? 4. Hypotenuse is what? 5. So I can write this as 4 by 5. Now it has become easy for you. Similarly, cos theta is what? Adjacent side by hypotenuse. Adjacent side is what? 3. 3 by 5. Correct? Tan theta is what? Opposite side by adjacent side. What would that be? 4 by 3. Good. Okay. So is that becoming clearer to you? Now, cosecant theta is again this by this. Okay. 5 by 4. Now check what is secant theta. Now it should be easy. By now it should be easy for you. So secant theta should be hypotenuse by adjacent side. What would that be? 5 by 3. Okay. And cot theta. What is cot theta? Adjacent side by opposite side. That will be 3 by 4. Okay. So with various numbers on the sides of the right angle triangle, you can, and this angle being theta, and this angle is 90 degrees, and you know that the opposite to the angle theta is the opposite side, and the side adjacent to the angle theta is adjacent side. Now, having known this, with any numbers over here, you can find the 6 ratios, because now you know what are the 6 ratios. So if you practice a little, you will become thorough in this. Once you are thorough with this, then subsequent chapters of trigonometry becomes much more easier for you. Okay, so like I told you, sin theta is 4 by 5, cos theta is 3 by 5. How 4 by 5? Opposite side by hypotenuse. How 3 by 5? Adjacent side by hypotenuse. Tan theta is opposite side by adjacent side. Okay, 4 by 3. Cosecant theta is hypotenuse by opposite side. 5 by 4. Secant theta is hypotenuse by adjacent side. 5 by 3. And cot theta is adjacent side by opposite side. 3 by 4. Okay. In fact, you can actually prove this to be correct when you come to identities. Okay. So we have something called identities, so which helps you to prove this is true, this is correct. Okay. Anyway, I'll come back to that a little later. I want you to start solving problems on these so that you become thorough with these basics. Once you are thorough, then you can go to the identities. Like supposing if I tell you, now you know what is sin theta, you know what is sin theta, you know what is cos theta. Supposing if I say, prove that sin square theta plus cos square theta is equal to 1. So you know what is sin theta. Sin theta is not 4 by 5. So what would this be? 16 by 25. 9 by 25 will give you 1. Okay, so sine square theta is what? So that means what? 16 by 25 plus 9 by 25, it gives you 1. Okay, there are many more, but I'll teach you all those things a little later. But okay, to begin with, let's practice and become thorough in the basics of trigonometry. Supposing I give you the sides as 1 and 1. Supposing I take this as an isosceles triangle, okay, with theta as 45 and this as 45, this becomes equal. It becomes an isosceles triangle and base angles are equal. So these two sides become equal. Okay, so this becomes an isosceles triangle. So in that case, I take this as 1 and this as 1. So if I take this side as 1 and this side as 1, what would this be? How will you find this AC? To find AC, what do? You normally use Pythagoras theorem. Okay, you know what does Pythagoras theorem state? It states that in a given right angle triangle, AB square plus BC square is always equal to AC square. Okay, that's what the Pythagoras theorem states. It states that AB square plus BC square is always equal to AC square. Correct? Now I want to find AC. I am given AB and BC. This is 1, this is 1. So 1 square is 1 plus 1 square is 1, and I get AC square as 2. But I want AC. AC is equal to square root of 2. Now I know this is square root of 2. Okay. Now tell me what would the if that be the case, now tell me the values of sine theta. So sine theta is equal to what? Opposite side by hypotenuse. Okay, so that will be 1 by root 2. Cos theta is what? Again 1 by root 2. Tan theta is what? Opposite side by adjacent side. 1 by 1 is 1. Cosecant theta is what? Root. Secant theta is what? Again root 2. We have root 2 by 1. I am not writing 1. Cot theta is what? Again 1. Okay. So we have seen that whatever numbers are given over here, okay, depending upon the angles or the numbers, you can now find these 6 ratios. Correct? Okay. But it needs a little more practice. If you practice it more, then definitely you'll be able to get it. Supposing if I take one more example. Suppose if I take this as an equilateral triangle. Okay, what happens in equilateral triangle? Oh no, all angles are equal, but sides we don't know. Okay, okay, and take some random values. Okay, so choose any values for these two sides and find, based on these two values, find the third side. Now you know how to do it. Okay, supposing if I take and 5. Let us try to find this value. So as I told you, how do you find this value? Using Pythagoras theorem. Okay, and what does Pythagoras theorem state? It states that AB square plus BC square is always equal to AC square. Now in this case, what is my AB square? 5 square plus 3 square. Okay, so let me see what do I get. This will be AC square. So this will be 25 plus 9. Maybe AC square. 25 plus 9 is what? 34. So my AC will be what? Root 34. Okay. So 34 does not have exact square root. Okay. So you can write only root 34. Now once you know all the three sides, you can easily write all these ratios again. Now you know what sin theta is. 5 by root 34. You know cos theta. What is cos theta? 3 by root of 34. Tan theta is 5 by 3. Cosecant theta is 1 by sin root 34 by 5. Secant theta root 34 by 3. And cot theta is 3 by 5. Okay, so if you remember this one, then anything given to you becomes easy. So what you need to remember, that these 6 ratios, how they are defined. Okay, as I told you, the shortcut would be SOH. Sin theta is what? Opposite side by hypotenuse. SOH, that's what I wrote, SOH. Cos theta is what? CAH. Cos theta is adjacent side by hypotenuse, so CAH. So cos theta is adjacent side by hypotenuse, CAH. Tan theta is TOA. So tan theta is T for tan theta is equal to O and A, opposite side by adjacent side. The others are opposite of these three. Cosecant is always 1 by sin, secant is always 1 by cos, and cot is always 1 by tan. Okay? Right. Now I think you can always check that tan theta is always equal to sin theta by cos theta, and cot theta is equal to 1 by tan, so that will be cos theta by sin theta. Okay, you can make a note of these things also. You can check also. It turns out to be true. Okay. So tan theta is what? Opposite by adjacent, opposite by adjacent. Okay. So that is what sin theta by cos theta. What is sin theta? Here 5 by root 34. What is cos theta? Root 3 by root 34. So if I divide both, 5 by 34 divided by root 3 by root 34, root 34 get cancelled. I get what? I get 5 by 3. And that is nothing but tan theta. Okay? You want me to do it? Sin theta by cos theta is 5 by root 34 divided by 3 by root 34. So this and this get cancelled. Ultimately you get 5 by 3. Which is nothing but 5 by 3 is nothing but tan theta. Okay, so far so good. So I'm just, the problems part of it, I'm leaving it to you. Take any textbook of class 9th or class 10th. You have exercises over there, exercise 1, 2, 3 on trigonometry. It starts with the initials of trigonometry, basics of trigonometry. Go through that and try to solve the problems over there. Okay, so the problem part, 1 or 2 problems I took to show you, to give an example. But you need to take some more problems from the books and then try to solve it. I'll just go to the next chapter and just try to give you a table and Now, normally this is a standard table given in most of the trigonometry, in many, almost all the trigonometry books, okay, and it's very easy for you to calculate sine 0, sine 30, sine 45, sine 60, sine 90. So, although you can derive it, calculate it yourself, but it would be better if you can remember it, okay, rather than each time going and trying to calculate it. So you have to memorize it. There's no other way of remembering it. But you can, if you wanted to remember, if you know how to derive it, that becomes easier. Okay. Now, if I take again show you that sine 30 is half. Okay, and sine 0 is what? I'll show you the easiest way. Sine 0 is 0. Half. 45 is again root 2. This is sine 45. Sine 60 is root 3 by 2. This is 1. Cos theta is opposite of this, so this would be 1. This would be root 3 by 2. This will be root 2, this will be 0. Sorry. And this would, you cannot, okay, 0. Okay. So this is what? Sine by cos. This is again, sine by cos is what? 0 by 1 is 0. This is what? Root 3. No, 1 by root 3. Sine tan 45 1. This one is root 3. This is not defined. Okay, so this is not defined because why? Because you get 0 in the denominator. Some books write it as infinity. Okay, because when the denominator is less, it's too less, and the numerator is high, then it is usually infinity, normally in physics. Okay, so this is, but basically mathematically they say this is not defined. So some books write as not defined, some books write as infinity. So this is how you can do it. You can also prove this. Supposing if I tell you that this angle is 30. Okay, if one angle is given to you, sine 30 is what? Half. Okay, that means what? Half means this side by this side. Okay, this is given to you, sine 30 is given to you half. I need to only find this side. How will I find? Again using Pythagoras theorem. So that would be 4 minus 1, 3. This would be root 3. Okay, now sine 30 is half, I said. So what would be the, try to find out cos 30. How much would it be? Cos 30, you know, is what? Cos theta is what? Adjacent side by hypotenuse. Root 3 by 2. You got it. Okay. So cos 30. Adjacent side by hypotenuse. Okay. Now tan 30. Tan 30 is what? 1 by this one. 1 by root 3. Tan 30. 1 by root 3. Okay. So this is where you can find out. The other three will be the opposite of these things. Okay. Now these if you remember it very well, it becomes easier for you to calculate, draw sums. Supposing if there is a sum, if tan, I can say tan 60 is root 3. Find the other trigonometrical ratios. Then what do I do? How do I do? Tan 60, this is 60. Okay, this is 90. Now tan 60 is what for me? Opposite side by adjacent side, root 3 by 1. Okay. Now I want sine 60. Sine 60 is what? Opposite side by hypotenuse, root 3 by 2. Okay. Now cos 60 is what? Adjacent side by hypotenuse. So that is how you can find out. If one this thing is given to you, ratio is given to you, you can easily find out the others. But for you to become thorough, you need to practice a lot. Take some exercises, take some problems from the textbooks, and then start practicing it. Once you practice, you get the hang of it, then it becomes quite easy for you. Okay. So for now, I think for me to revise, I'll just revise and leave here. We'll end up here, and then it's up to you to practice. Okay. So let's revise what we have done. So we defined what is trigonometry. Okay, the definition of trigonometry we said. Okay, so how did we define trigonometry? We said trigonometry is that branch of mathematics which deals with the sides and ratios of the sides and angles of a triangle. Okay, and what are the 6 ratios we said? We took a right angle triangle. We always take a right angle triangle. If this be theta, if this is 90, then what did we say? This is ABC, and the side opposite to the theta is called as the opposite side, we said. Okay, this is the opposite side, this is the adjacent side, and this is the hypotenuse. Okay, so we said sine theta is equal to opposite side by hypotenuse. So we said sine theta opposite side by hypotenuse. So how did we define cos theta? Cos theta we said adjacent side by hypotenuse. Okay, tan theta opposite side by adjacent side. The shortcut of remembering this is sin theta is opposite by hypotenuse, cos theta is adjacent side by hypotenuse, tan theta is opposite by adjacent. Okay, so in short you write it as sin theta, you write it as SOH, opposite by hypotenuse. Okay, and cos you write it as ANH, tan you write it as ONA. Okay, opposite side by adjacent side. So the remaining 3 are opposite of these things. That's what we discussed. Now I also told you we did this, so now you know all these things. After this we took up some problems. We said if this is 3, 4 and 5, so I showed you if this is 3, 4 and 5, okay, then what is sin theta? Sin theta is 4 by 5, cos theta is 3 by 5, tan theta is 4 by 3. Okay, so the remaining will be opposite of that. Cosecant theta is 5 by 4, secant theta will be 3 by 4, tan theta will be equal to cot theta will be equal to tan theta is 4 by 3, so cot theta will be 3 by 4. Okay, 1 by tan. So all these things we studied. Remember these things, practice by doing a lot of problems, and then you will get a hang of it. Then after this I told you, showed you this table. Okay, so this table, if 0, 30, 45, 60 and 90 are given to you, you should remember the values of each one of them. Okay, so sine 0 is 0, sine 30 is half, sine 45 is root 2, sine 60 is root 3 by 2, sine 90 is 1. Cos 0 is 1, it goes in the opposite direction. Cos 0 is 1 because cos theta is nothing but complement of sine. It's cosine, complementary of sine. So it's complementary of sine, okay. So cos 0 is 1, cos 30 is root 3 by 2, cos 45 is anyway root 2, cos 60 is half, cos 90 is 0. Tan, sine by cos, this will be 0. Tan 30 is 1 by root 3, tan 45 is 1, tan 60 is root 3, tan 90 is not defined. In some books they write it as infinity. Okay, so it depends. I think you know how it is different. And suppose if I take 10 by 5. No, I'll take 10 by 10. What do I get? 1. Sorry. If I reduce the denominator, 10 by 5, what happens? This value increases. As the denominator decreases, this value increases. Supposing if I take 10 by 2, what happens? 5. So as the denominator goes down, this value increases. I take 10 by 1. What happens? 10. So what do we observe? So as the denominator value decreases, this value increases. Then if it goes further down, so would this value be higher or lesser? It would be much more higher. That is one of the reasons why they say it is infinity. How do you write infinity? Okay. So that is the symbol of infinity. Right? Is that clear? But because 1 by 0 is not defined, so 0 cannot be in the denominator. So because 0 cannot be in the denominator, rational numbers, if you remember, recall your rational numbers. How do you define what is the rational number? The rational number is defined as p by q, any number in the form of p by q, where q is not equal to 0. So because of this, we say this is not defined. Okay, so I showed you both the reasons, right? So we are going to end here. We'll stop here and then come back in the next chapter for with the problems. Is that okay? Okay then. Thank you. Take care. Bye.